now. Okay, so today's session is about circuit fundamentals, meaning the first session. The second session by Juho Vesanen will be actually about Arduino basics. Yes, we are using Arduino. There's good reasons for that one. We also actually have a small change in plans. We've heard something just yesterday, but I will tell you that one later. The documents actually is holding this information about, okay, see again, information about different weeks. Currently we have published only first and second week, but we will have 8 weeks of classes during these lectures. And then we also have weekly assignments on both morning session and afternoon session each. So in principle you will get about 16 small assignments or so. Okay, so the first 2 weeks assignments are already there, but I think yeah, those should be published already. Okay, let's go to the and start with the fundamentals, since it also have about the brief introduction how we are going to work on this one. So contents. Contents is roughly about that one. This is the version 1.0, so first publishable version. And on the course description, there are those 4 bullet points, meaning fundamentals of electronics in embedded systems, electrical components and basic of circuit theory, and the modular system design, and finally embedded software and hardware integration, which are really wide topics. Each of these could be easily be 5 credits each, so this is introduction to those topics. And well, you can read yourself introduction. Today we have introduction to circuits and Tinkercad. Okay, you read my announcement. There was a request to install not install but register to Tinkercad, and some instructions how you can register without giving your own email address if you hesitate to do it. I would trust actually Tinkercad to have pretty safe environments in this. It's a product of Autodesk, which has been one of the leader or the leader electronics design, electronic and mechanics design, the software companies in the world. So if you have heard AutoCAD, with this industry standard actually, the AutoCAD is one of the Autodesk products. And then on afternoon you will have the Arduino, and then roughly something like that. Next week 2 topics again: circuit analysis on the electronics part, and then interrupts on the embedded software part, and so on. In addition to this one, we actually heard this yesterday afternoon that we also, or not we, you should do one of the Cisco courses here, which are internet courses, and quite a lot of exercises, small exercises. In addition to that, we will have a Cisco learning material for that one that me and Juho will go through with you. Okay, and that's basically covers the 13th part, what. At some point we start mixing these lectures with the Cisco stuff. Okay, about assessment criteria. is based on the assignments. We will have these weekly assignments, and each of those assignments gives you a maximum of 10 points. At the end of the course, those points are summed up, and your final grade depends on the percentage of the total maximum, meaning that if you are shooting for the highest possible grade 5, you need to do practically every single exercise, and you don't have too much room of error there. On the other hand, these exercises don't usually have too many tricky questions or trick questions. Yes, they are tricky to solve. You need to use your engineering problem solving skills or practice your engineering problem solving skills, but they are quite, say, straightforward. I have 20 years of expertise of making these exercises, and usually students haven't complained too much about them. On the other hand, this is also the first time I'm giving this class, so if you have, say, complaints or opinions about the exercises that they are too hard or so, please feel free to give me feedback. Sometimes I make small, say, tricky things without thinking. On the other hand, also my colleague Juho Vesanen has gone through, and he has also quite long expertise on the teaching. So I would guess this is quite okay. Let's go now through the exercise instructions briefly. There's a link for that one. Exercise instructions. There. Let me make it a little bigger. Quite straightforward. Oops, sorry, there's some latency on my system here. So exercise instructions quite simple. There will be a template workbook. You make first the private copy. Don't try to edit that template since it's linked to my file on Google Drive. You can download it as Word document, that's up to you. You might actually, if you do downloading, then you might actually lose some graphics or something like that. But on the other hand, you also have these Metropolia organizational Google accounts, so I would recommend using those for this course. Then rename your copy and put it somewhere that you can find it. Then you need to add your name on the research box and so on. What I would like to point out here is this one. At some examples, you need a semi-random number, SSS. In those exercises, you would actually take your student ID and take the 3 last non-zero digits of your student ID. So if there is a 0 in between, like in here, 2, 3, or 4, then you skip the 0 and your 3 last non-zero digits is 2, 3, 4. Okay. And again, I kind of trust that you can read the rest. Okay. So we have assignments. All assignments give maximum 10 points. Then that's the percentage. You need to have at least 40% of the exercise points in order to pass the course. Do you need to return all the exercises? At least for the circuits and Arduino part, no, you don't need to if you have enough of points and say, okay, this cannot be less interesting, or it could be, but then okay, then you can actually skip the exercises. I don't really mind if there are some of you will shoot for the lower grade, just passing grade. That's okay. It's up to you. Anyhow, tools. Tinkercad. Tinkercad, uh, we use that one for circuit simulation environment, and also it has Arduino simulation. So you probably have heard Arduino. It's a small AVR based or okay, it could be also ARM based nowadays, but mostly AVR microprocessor based small computers with a common language C. It resembles C language, or actually it's on the top of the C language. There's its own subroutine libraries and its own way of things that actually things work. And but anyways, why Arduino? Well, we are not going to make anything really big here. So ARM processor would be probably the better option, but since we don't have on-campus classrooms, this is still COVID time, then basically we need to take some processor environment which has a simulator, a good simulator with also the gadget and stuff. So also simulate the surrounding electronics. So for that one, Tinkercad gives a quite nice tool. Okay. Another tool, of course, Zoom. Yeah, and I see you have found it. By the way, somebody could put on the chat window if you found this link also from your calendar. So for some reason my colleague also did the same thing as I did, but his calendar marking doesn't show this Zoom link. So anyone, but on the other hand, you can find this link from the OMAP workspace, no problem. Another tool here is the IFTTT. I don't know if you have heard of that yet, but it's if this then that. Later on we'll visit that one, but it's basically one of these IoT the platforms available. Okay, then Tinkercad. I hope you have already registered to Tinkercad. I cannot find any way that you could survive this course without it. So basically it's very simple tool. After you once you log in, you can start designing. It's started with the 3D design platform. Then it came also with the circuits, and now there's something new, which is code blocks, which more or less it kind of combines this circuit stuff or programming of things with 3D design. So, for example, it can be used for small animations. But in this course, we deal with the circuits. Okay, now a simple demo, I think I could actually start it from here. Or actually I can build it just for fun. So I'm opening first the Tinkercad. First open the Tinkercad and then we take a look at the circuits. Sorry. It seems that this really, my keyboard is somehow pressing the control key all the time. That's no good. And create new circuit. When you create a new circuit, it actually opens up like that one. Let me zoom it a little. Can I zoom it? I should be able to zoom this. Okay, there we go. A little bit bigger. So that's what it looks like. I have a lamp, a push button, and a 9-volt battery. And basically, so here's the push button. Just add that one here. Then I need the battery, 9-volt battery, and then let's see, let's search for lamp. Is it here? Nope. Okay. Now the control is pressed and I cannot type anything here. No. Sorry. I will just take it from the link. How would you make that one? "54 seconds without any audio." Okay, create new things. Oh, this is called the backup plan. So there's a battery. There's also that demonstration as a YouTube video just in case. Okay, bulb. And then putting some wires. Adjusting a little bit. And there we go. Okay. Tweaking, meaning this should look nicer. And when you start the simulation, you can press that small button there. Okay, there we go. Simple simple program to make some circuits and test them. Okay. So that was about the tools and stuff. Do you have any questions now about the previous things like contents, assessment, tools, registration?
So how many assessments there are going to be?
Every week, 2. So in total there will be 18 assignments. About I don't know about how many assignments that actually they are on that Cisco part. So that's unknown yet. I will get that information for the next week though. Which Cisco course? In Cisco course, there's the, let's see, I need to, which Cisco course? That basically, just a moment. Since this course actually is the prerequisite for the next IoT Connecting Things course, which is on the starts on mid March, and here we have Cisco Academic course IoT Fundamentals, Connecting Things. Yeah. Yes. So the Cisco Academy IoT Fundamentals, Connecting Things part. Okay, you will get instructions later on. Okay. And there were a couple of chat questions there. Let me try to make this one a little bit bigger. Screen share is quite blurry. Yes, I have a low, quite low bandwidth, so sometimes it can get blurry. I have something like 1 megabit per second on 1 megabit per second on upstream. I live in on countryside using 4G. I see the calendar link, but not sure if it is the right one. Okay. Okay, it's on the calendar. Okay, it should be the correct one. Okay, you want to have sticky key. Sticky key. Probably. Okay, but actually, yeah. Ha. Yes, of course. Yes, blurry. I have quite nice, and I'm actually looking at the original here, but I'm also recording this one, so if there's something really that need the details, that'll be available later on. That'll be on the high resolution. Okay. Nurturing from no, it's actually yes, it's this is not. This is actually quite far away from the next closest. The antenna, it's about 2 kilometers, and that's not good. Not good for 4G. I get much better on my other house in Kerimäki, which is at the middle of nowhere. It's funny. Okay, but anyways, let's go forward. Let's go forward. So please
I still
tolerate with me. Yes.
I have a question about the grade still.
Yes.
Did I understood correctly? So the grade is only based on the assignments, and the
Yes.
for example, the Cisco course doesn't have any affection on that.
It also have some assignments there. You need to do the stuff. I haven't talked with the with Juho yet. We will. It's either that we give all. Well, I don't know yet. This came out of the woods for us, so it doesn't say anything on that the course description. Actually, it is also a prerequisite for the next course, which is based on Cisco. So this is totally new for me. So I need to take a look what kind of exercises there are. There are two options. One is that we don't grade those at all. Another one, it's either 0 or 10 points. As I understand that the Cisco assignments or Cisco exercises there, You just do it as long as you pass it. You need to pass the tests. If I have understood it correctly. So in that case, it will be quite nice since, well, in order to pass those parts would give you automatically 10 points. But anyways, I will talk with Juho about this one first. Cannot make a decision myself. Okay, next. Let's start a little bit about the circuits in Tinkercad. And also about the circuits. I talked with Timo Salin about how much you have the electronics in physics, and he said that not too much. Some of you with the vocational school background, probably this might be actually a review of what you already have learned. I think also in high school, some high schools, if you take the long physics, some of that stuff has already been there. But I'm also sure that this is totally new for some of you, so that's why I start from the bottom. Only one place to start. So today, if I can go through all of this stuff, I'll be pretty happy. Ohm's Law, and then series and parallel connection, basic measurements, power, electric power, LED, and how to turn on the LED. So this is not much, but this is fundamental. Fundamental, and next week it'll get harder, or it'll get more stuff. First, some of the basic elements, basic DC elements, direct current, meaning that not alternating current. We are dealing only with the resistors and voltage and current sources. So resistor, two markings. In Europe we have that box, open box with marking inside, or it could be also outside. In United States they use that funny wire kind of thingy. So if you see that kind of electric drawing somewhere, don't mix this one with a electric coil, which is quite similar to this one. But we are using this resistor, this circuit element as a box, and then it has two terminals. Or three terminals, so variable resistor. So this is the variable resistor marking R2, and then what the size is here somewhere else. 10K means 10 kilo ohms. And then this is the variable part, so it has an arrow and third terminal. Practically this arrow is a conductor between a resistive or the somewhere on the resistive area. So this you actually get a variable resistor between this terminal and that terminal, and also inverse of that between the center terminal and the other terminal. So two variable resistors practically. And on the electric drawings, omega is usually omitted. It's not on the standard keyboard. I think that is the one of the reasons. Okay. So usually that omega is omitted. So if we have a 123 ohm or some ohm resistor, then if it's marked as 123R, then R actually means that it's just ohms. Okay, 22K means 22 kilo ohms. 1M2 would mean 1.2 mega ohms. So basically this can be used in electrical drawings to show the decimal point. Okay. Then of course conducting wire, so the resistance is negligible compared to other resistors here, meaning other resistor meaning all conductors except superconductors resist electric current. Okay, so conducting wire is actually just low resistance long resistor. Current junction should be clearly marked, so meaning if there's a real connection there on this higher, there's a junction is marked with the black dot, and on lower it actually uses a constant color. Then if it's one single color line, then you don't necessarily need that dot there. On the other hand, to have a clearly marked current junction, you should have that dot there. Okay. One thing also to keep in mind when you have a resistor, it also consumes electric power, meaning that it heats up when you turn current on it, and it also means that there are some power ratings for the resistors. But I will be telling more about that one later on. Other DC elements here, voltage sources. This here actually is reserved for battery, and then you mark the this voltage, for example here. But anyways, this basically the battery is old symbol. This long thin line is the positive terminal, and this thick short line is the negative terminal. So for example, battery low. Okay, what is a characteristic of voltage source is that has very low internal resistance in series with this battery or energy source, voltage source. Sometimes the voltage source has just this negative and positive terminals marked. Sometimes it has the voltage marked and the direction of the electric field, meaning from positive to negative. So this marking here is showing that we have a electric field from higher to lower potential. And okay, that's a model for the voltage source. Common ground, actually those are the lower ones here. I hate when that thingy comes here. So that lower one here, so we have, can I move that one somewhere else? No, I cannot. Shoot. Let's wait for a while. Okay, so that the GND, ground, meaning just a reference ground potential. Usually for digital ground or common ground, you use that symbol. If you have analog ground, meaning there are some noise sensitive circuits, and you want to have a common analog ground separately, then you would mark it as a triangle down with one terminal. This old-fashioned grounding marking with those three parallel lines actually is reserved for case. So it's a protective enclosure ground, which should not be directly connected to any of the other grounds. Otherwise, the enclosure will work as an antenna for all electromagnetic interference. Okay, if we have these common ground symbols, those are actually unipolar. In order to get any current flowing, you actually need to have at least bipolar systems. So in addition to these markings, then you would need the these power supply voltage markings. So plus 5 volts, for example, like that, or VCC. Doesn't say it's positive or negative. Well, I would say it's positive just because. And then we have this negative voltage power supply, and then these terminals. Okay, so some say now you can start to learn how to read the circuit diagrams. We also have then the current source. It basically means constant current for our DC, which has very high internal resistance in parallel of the system. And there are two markings. For example, you have this European marking showing the what is the current value, 1 milliamp constant current. This way the arrow shows the direction. In the United States they use this little bit awkward symbol. Well, in sense it makes maybe a little bit sense. It shows that this device have a high internal resistance, and it's a current source because there is the current flowing from it. Practically, current sources are not used that often on the circuit designs unless you are designing a constant current power driver for LED. Okay, this is one of the 4 most important equations on electronics. Ohm's law, which states that the voltage drop over a resistor is equal to the resistance times the current which is flowing through it. Okay, I think I had a Tinkercad here, so circuit design. Yes, I can simulate that one. There's a resistor and there's a voltage supply, power supply. So practically when we turn on the crank up voltage is here on the current voltage supply, you also get the this current flowing through, which is proportional. Actually, this voltage is directly proportional to the current and the resistor value. So as you can see, that these are basically, there's just a constant multiplying factor in between of those, which seems to be 10 kilo ohms. Yes. Okay, so Ohm's law works. One small thing to remember here is that it's voltage potential difference. So when we are talking about voltages, there's no such thing as unipolar voltage. It's always voltage difference. So in here the voltage difference is between the left terminal and right terminal of that resistor. Wow. And now we have about 5 minutes break, so we have about one full lecture already done. So okay, unless you have any questions. No questions. So we have all clear. Yeehaw! We will continue at 9:50. Ah, yeah. I try to find what the heck is wrong with my. Do you get wire junctions in Tinkercad? Yes, I will show that one later. There's the question: how do you get wire junction in Tinkercad? It actually it's pretty easy. You just connect a wire. Start a wire from terminal, and then you can also connect. Oh, actually, you need to connect that to. Easiest way is it connect to the terminal. Okay, so 5 minutes. So we will be back at 9:51. Ha. That works.
You mean 9:52, right?